Hey guys, welcome to the lesson today. Today we're going to introduce you to 12.2 probability and counting. And today we're going to review a little bit basic rules for probability. And my worksheet is uploaded on Google Classroom. Please pull it up before you watch the following video. Okay, I hope you are ready now. And first of all, I have 4 cards on my hand. Okay, each card have one student's name: Abby, Billy, Kathy, and Danny on there. Okay, so first question, I want to review what's going on last time. What is the sample space if I randomly draw one card from the deck? Okay, so first of all, the sample space means all the possible outcomes. If I draw a card, the card can be Abby. If I draw a card, the card can be Bailey and can be Danny or Kathy. So over here, my sample space will have 4 possible outcomes. So let's look at this worksheet. So the possible outcomes for drawing one student can be either Abby, can be Bailey, can be Kathy, can be Danny. Okay, so this is my sample space. And right here, what I did is I make a list. So I have totally 4 possible outcomes. 4 possible outcomes. Okay, and then my next question is, what is the probability of drawing Kathy? So we know that we have 4 cards. Okay, so you have 4 possible ways to draw stuff, and Kathy is one of the card. So my probability will be 1 out of 4. Okay, all right. So let me put you back to my screen. So the probability of drawing Kathy will be 1 out of 4. Oops. If you write it as a fraction, let's be more professional. Let's write it as a fraction. Okay, this does not work this way. All right, 1 out of, okay, hello. All right, 1 out of 4 is my probability. So according to the probability formula, the formula of probability of an event, on the top will be number of favorable outcomes. So in this question, on the top, I have, okay, where's my arrow? On the top, I have outcome. It's called Kathy. Okay. On the bottom of the fraction, we have total number of favorable outcomes, which is our sample space. All possible outcomes, which we have 4 possible outcomes. So this is how you get your probability. I hope that makes sense to you. Okay? All right, next one. I want to, you're gonna try this 4 questions. Okay, if you want to pause the video here to actually try it, please do so. I will just gonna keep going, but if you need some time, please pause your video. Okay, all right. So number 1 is saying, what's the probability of drawing Danny? So drawing Danny again, if we just want to draw Danny, Danny is 1 out of the outcome. Okay, and all the outcome we have in this question is 4. That's my total outcome. So it's 1 over 4. Okay, this is not working. Okay, 1 over 4. Okay, all right. Number 2, they said, what is the probability of not drawing Betty? So let's look at all our outcomes. I have Abby, Billy, Kathy, and Danny. So not drawing Betty, I can either draw Abby, Kathy, or Danny. So that will be 3 of the outcomes. So over here, my answer will be 3 over, again, the total outcome is 4. Okay, this is, I don't know how to use my keypad. Okay, 3 over 4. So over here, a lot of time you will see at the beginning there was a P and a letter in there and equals to something. This is pronounced as probability of event joining a Danny is our D. So let's define our D. D is my event joining Danny. So over here I have probability of joining Danny is equals to 1 out of 4. So let's be more precise over here as well. So let's do probability of not joining Billy. Or you can say probability of not, since we use B, we can use B for to represent joining Billy. So B is join Billy. Not B is equals to 3/4. So why I write like this? Because when you do your ALEKS practice, there are a lot of different ways to represent stuff. I want you to know what they are talking about, okay? So over here, that's B. What is the probability of not joining Billy? And C, what is the probability of joining Abby or Danny? So if I said, again, let's define our event. So I will use A as join Abby, and my B is join Danny. And then my probability of joining Abby or Danny will be Abby or Danny. That's 2 outcomes out of my 4 outcomes. When you see something you can simplify 2 over 4, you can simplify it to 1 over 2. Alright, so this is the answer for practice problem. Okay, it's not very hard. You just need to think about what is the desirable outcome you put on the top and what is all the outcome you put on the bottom. Okay, all right. So another thing I want to mention is this definition. What is complement? Event not joining Billy is a complement of event joining Billy. So it basically, if you put a not in front of something, that's a complement event. So for example, you can over here we have join Danny, you can do not join Danny, and you have join Abby or Danny, you can say not join Abby nor not join Danny. Okay, so they have a formula over here. If you want to calculate the event of P probability of not A, you can use 1 minus probability of A. So how does that work? Let's look at this example again. I will use a different color. So we said the probability of not B, according to the complement formula, is equals to 1 minus probability of B. Okay, so we said 1 minus probability of joining Billy is 1 over 4. So the probability of not joining Billy will be the same over here, 3 over 4. Okay, do you see if these two answers match each other? So in the future, you can either lay them out and find the event actually which outcome is not Billy, or you can just simply use which outcome is Billy and use 1 minus that. This is for complementary event. Okay, all right. So far we learned how to calculate probability, use the formula, and what is the complements. All right, let's keep going with the event. If we draw 2 cards at the same time, right now it's not one card. We're gonna draw two cards at the same time. So how does that work? Is again, okay, over here I have four cards, and if I shuffle them, all right, and I'm gonna draw randomly two cards. Okay, I'm now looking. Draw two cards over here, and you can see my result. All right, is that backward? Yep. You can see my result is Kathy and Danny, and we want to see what combinations, what possible outcomes are there in the sample space. Okay. All right. So let's get my screen back. Let's write it down. What are the possible outcomes? So first of all, in my example, I drew Kathy and Danny, but let's do it in order. Let's try to do Abby. You can draw Abby and Billy, okay? You can draw Abby and Kathy, and you can draw Abby and Danny. I do it this way to lay out just to make sure I do not miss anything, okay? All right, so you can also draw Bailey, and Bailey Abby, I already put it here, so I don't include Bailey Abby since we are drawing two cards at the same time. Bailey Abby, Abby Bailey are the same thing. Bailey Kathy, and we can do Bailey Danny. Or we can draw Danny. Hold on, I missed Kathy. I'm sorry, Kathy. Kathy and Danny. Okay, and the last one you can start with Danny. But if you think about Danny, Abby, you already have it. Danny Bailey have it. Danny Kathy have it. So we do not need to start with Danny. This is all possible outcomes. And the list over here is called sample space. And how many possible outcomes we have? 1, 2, 3, 4, 5, 6. 6 possible outcomes. Okay. All right, let's find our probability. So what is the probability to draw Kathy and Danny? So again, we need to find what is the all the possible outcomes in the sample space. So we just did is 6. So on the bottom of the fraction will be 6. Let's do the bottom first this time. All right. So again, our good habit. Probability of drawing Kathy and Danny, okay, is equals to on the bottom, we have 6. On the top, let's see, Kathy, Danny, we only have one outcome, so over here we have 1. 1 out of 6. That is the probability of draw Kathy and Danny, okay? All right, so next one. They ask you, what is the probability of drawing Abby in one of these cards? So Abby in one of the cards. That probability is equals to, think about it, Abby in one of the cards. It can be what? Can be Abby Bailey, can be Abby Kathy, can be Abby Danny. So they have 3 possible outcomes. So what you're gonna put on the top? Will be 3. Awesome. 3. On the bottom is all the possible outcomes will be 6. All right, you know what? Let me making sure if I'm still recording it, because if I'm just talking without recording, I'm not doing the right thing. All right, awesome. So 3 over 6 is our fraction. Okay, and again, you're gonna simplify it. You gotta get 1 over 2. Okay, so what is the probability to draw Abby in one of these cards? Is 1 over 2. So half the card you draw, it will be half that Abby. All right, it seems like a lot, right? Yep. And also, if you do, what's the probability of draw Danny on one of the card? Again, you have 3. So if you're gonna, the probability of draw anybody in one of the card will be 1/2. All right. So this is again, it's the same problem with the first one. Instead of just drawing one card, we're drawing 2 cards here. Okay, another thing I want to mention, and none of this notation gonna use in this chapter anywhere you see in Alex, but I want to let you know what does this U sign and this like this upside down U sign means. This U sign is called union. Union means two events is in either of the outcome. The union of two events is the set of outcomes are either event. The union of event A and B is represent A and have a U, B. We call it one A union B or A or B. The section of two events, it's the intersection of the event is A and B, and we use this symbol upside down U, and this looks like N. We call it N. It's just an easy way to remember it. I do not want to talk too much about it since it's not the concept of this unit, but I just want to show you very quick what does this means. So let's give you a quick example. All right. So okay. So let's have two of my students, okay? Let's say Ava and Peter. All right, so I asked them, hey guys, what you guys had for lunch today? And then Ava said, okay, I had a hot dog. Okay, and I have French fries. All right, my camera is not zooming there. All right. Hot dog, they have fries and a Coke. Alright, and Peter said, I have a hamburger and fries and water. Okay, so if I want to use a Venn diagram, which is what you see in the note to represent the food they eat, so what I will have one circle is what Ava ate, okay? And one circle is Peter ate, okay? And over here, the union, they said, is either or. So like the union will be the food Ava or Peter eat. That will be in the whole entire circle. So that will include hot dog, fries, Coke, hamburger, and fries again, so we do not need to include that again, and water. Okay, so this is A union B, or you say, or it's equivalent to A or B. So over here is Peter or Ava, so they have hot dog, okay, all right, fries, Coke, hamburger, and water. This is your A union B, okay? And A and B is A and B, which means Ava and Peter both ate for lunch, which is intersection over here. What is over here? So what they have both ate for lunch? Just fries. Okay, so over here the intersection is just fries. And on the left, what Ava ate is hot dog, Coke, and also the intersection fries. So Ava ate hot dog, fries, and Coke. Peter will have hamburger, fries, and water. Okay, so this is basically Venn diagram without the total like rectangle. So this is not really a real Venn diagram, but it's a straightforward way to help you understand what does or and means. Okay, all right. So let's look at some example, then we will finish today's lesson. I understand I probably put too much into this lesson, but if you can understand what's going on here, I believe you already understand maybe 30 or 40% of what we're learning in this chapter. All right, so let's put my display back on. Let's do some practice problem. And again, for each question, or like if you want to try it right now, please pause the video and try it yourself and hear my explanation. Okay? All right, here we go. So consider the experiment of picking one of the 12 months of a year at random. Find the probability of picking each of the following. Okay, so again, I want to first off list all my possible outcomes. 12 months, January, February, March, I know I will spell something wrong. April, May, June, July, August, September, October, November, and December. Okay, let's fix the February very quick. All right, so there are 12 possible outcomes. So they said a month of the year that starts with a letter J. Let's look at it, okay? So we're gonna write down the probability of a month of the year start with a J. I will just copy the event, put it in the middle. Oops. Okay, so on the bottom again, it will be how many possible outcomes you have. Over here we have 12. So I will put the 12 on the first. Okay. On the top, there will be a month of the year that starts with a letter J. Let's look at it. January 1, June 2, July 3. Anything else? Nope. So 3 out of 12. Simplify, you got 1 over 4 divided by 4 on the top and the bottom. Divided by 3. My bad. All right. Okay. So this is the first question. A month of a year will start a letter J. The answer is 1/4. Second one, a month of the year that ends with a Okay. So I know it sounds weird. Okay, I just gonna copy everything here because I know the bottom will now change. Okay, let's erase this. Oops. All right, let's just leave it here. A month of a year that ends with a Okay, let's look at it. January is not, February not, March not, April not. September 1, no, October 2, November 3, December 4. So it will be 4 out of 12 divided by 4 on the top and bottom. 1/3 is your answer. Okay, all right, it's pretty straightforward, I will say. Okay, all right, let's look at next question. If you have a 40% chance of making a free throw, what is the probability of miss a free throw? We said miss a free throw is actually not making a free throw, so that is the complement event. So probability of missing a free throw is actually probability not a free throw, not making a free throw. Since it's a complement event, we use 1 minus the probability of the complement making a free throw. Okay, which is 1 minus 40%, which is 60%. Okay, so this question is about complement event. Question number 4. What's the probability of spinning a spinner number 1 to 6 not landing a 5? So again, they have not in the question, so you need to think about what is the opposite of not. So probability of not landing on 5. What's the opposite of that is 1 minus the probability of landing on 5? What is the probability of landing on 5? Will be 1 on the top, because landing on 5 is landing on 5 is just one of the event. And how many number they are? 6. 1 over 6, which is equals to 5 over 6. Or another way to think about this problem, you can think about probability of not landing on 5 is actually the probability of landing on 1 or 2 or 3 or 4 or 6. Okay, you do not need to use your knowledge in complement and to solve this question. So landing on 1 or 2 or 3 or 4 or 6, that will be 5 total possible outcomes over the total 6. You can also either use this way to get your answer. Okay, so here we go, the last question. Consider the experiment of drawing a card from a standard deck of playing cards at random. Find the probability of selecting each of the following. Okay, so for the standard deck of cards, you need to know. So in each deck of cards, they have 52 cards. Okay, and 13 of them are heart. Ooh, I don't really know. Okay, 13 of them are heart. It's from 8th to ace, 2, 3, and all the way to 10. And then you have J, you have queen, you have king. Okay, and then you have 13 diamond, and it's the same thing. Okay, all right, diamond. It's the same thing from A to 3, 10 to J to Q and king. And you have 13 club. Okay, you have 13 spade. Ooh, I can name all of them. Look at me. All right, so there are totally 52 cards in a standard deck of cards. Some of them have jokers, but we're not talking about it here. All right, so they said the probability of draw a 2 or a 8. So if you want to find the probability drawing 2 or 8, you need to think about how many outcomes are there. So first of all, let me write it down. My event, a 2 or an 8. Okay, so all the possible outcomes obviously is 52, since there are 52 cards. So on the bottom, you have 52 cards. On the top, you will have 2 or 8. So on the top, you're gonna think about what 2 you can possibly have. So how many 2s in a deck of cards? There are 4 2s. You have heart 2, diamond 2, club 2, and spade 2. So you have 4 2s. And 8 is the same thing. You have heart 8, diamond 8, club 8, and spade 8. Okay, so totally you have 8 possible outcomes you want to get. So on the top will be 8. Okay, let's simplify it. So when you simplify it, basically you are doing dividing a number on the top and bottom. Let's see if we can divide by 8. Nope, you cannot divide by 8. So let's try if we can divide it by 4. Okay, most certainly you can divide it by 4. So let's divide it by 4 and see what is on the top. 8 divided by 4 is 2, and on the bottom divided by 4, it will be 13. Okay, 13, 2 out of 13. In this question, you can also think about what's the probability of 2 and 8 in one suit, because all the suit, it will be just times a number on the top and bottom. But if it's beyond like what you can understand, just think like this will be fine. Okay, all right, next one, they ask you what is the probability of having a club. So my probability of club. Okay, so how many club cards on there? So according to my introduction for the club card, we have 13 club card in a deck. So 13 on the top and total card number on the bottom will be 52 cards. And you divide it by 13 on the top and bottom, you got 1/4. Or another way, like a kind of a smarter way, but you don't really need to understand if you can't. To understand this is in each suit they have same amount of card, and the club is one of the suit. We have 4 suit, so it's 1/4. Okay, either way is fine, and totally fine that you said 13/52 and simplify. That's a perfect way to do it. All right. So, okay, let me see why you cannot see me. All right, so, okay, so basically this is our lesson today. Give you a quick summary. We learned the basic formula to find a simple probability, which is your like the how many outcome you want on the top, and all the outcome you can aggregate on the bottom. And then we learn what is complement. Complement event of A is just simply put a not in front. It's not A, or you can think about it as the opposite of A. And then we learn the symbol of or and, or the symbol of or looks like an upside down U, and the symbol of okay, I take it back. The symbol of or looks like a U, and the symbol of and it's an upside down U, and because in the end AND you have N, this looks like an N. Okay, and the last thing, I guess that's all we learned today, and I gave you a bunch of examples on the bottom. Please finish your assignment, and if you have any question, you can send me an email or comment on the comment section on YouTube. I will answer it. Okay, I hope you have a great day. Stay safe, and I will see you next time.